Okay, we're going to learn about completing the square. And this is section 3.3 of your text, completing the square. As a method of solving quadratics. So we already know some methods. We're going to use this one too. So just to get you warmed up a little bit here, what this really means is, like, if we have a situation where we have like x squared plus 10x plus some number c, we're trying to figure out, like, we've got ax squared plus bx plus c. We're trying to figure out what value of c would make this a perfect square. And so what we do is we take our 10 and we divide it by 2, and then we square it. So we take our value for b, whatever it is, divide it by 2, and square it. And that's going to be our c value. So 10 divided by 2 is 5. 5 squared is 25. So we would want c to equal 25. And then we would rewrite this as x squared plus 10x plus 25. This allows us to factor into what we call a perfect square. So x plus 5 times x plus 5 is a perfect square. It's something times itself. X plus 5 squared. Okay, so for instance, like 2 squared, 3 squared. This is x plus 5 squared. So we have a number squared. We call it a perfect square trinomial. 1, 2, 3 terms is a perfect square trinomial. So that's our goal. Trinomial. Okay, great. So we're trying to create this perfect square trinomial. So let's do another one. If we have x squared plus 14x, we're wondering what number should we add here for c? Well, we'll take our 14 divided by 2, that's 7, square it, we're going to get 49. That number, that b divided by 2, is actually going to be the number that we see in our perfect square trinomial. Notice when we did b squared divided by 2, we had 5, and notice we have 5 here. Well, same thing here. 14 divided by 2 is actually the number here. So you don't have to always go through all the factoring if you know that that's what this is going to generate. So that's our pattern that we're following. And the general algebraic pattern is ax squared plus bx plus c should lead you to x plus d, some new number, squared, where d equals b divided by 2. And c is going to equal b divided by 2 squared. All right, so that's the general pattern that we're following for finding a perfect square. But how do we do that to actually solve a quadratic? Well, here's an example. I'm going to draw a little line here delineating this. Okay, so if we have x squared minus 10x plus 7, this one's a little interesting because we have a minus here, so that's going to change the sign for us a little bit. But we're going to, let's say this all equals 0, right? So we're going to set this equal to 0. So now we have an equation. You can only solve if you have an equation. Otherwise, it's just an expression and there's nothing to solve. So everything we were dealing with up to now are just expressions. We're rewriting these expressions. Now we're going to be able to solve what values of x would make this equal to 0. And we know many methods. Our methods so far, just a little recap here. Remember, we can graph. We can try to factor. We can take square roots, if possible. And then now we're learning this completing the square method. Okay, so our first step is actually going to be to move this 7 to the other side. What we'd like this number to be is 25, right? So b equals 10. If we divide that by 2, that would be 5. In fact, it's negative 10, right? Let's bring that negative in here. And so b over 2 is actually negative 5. But b over 2 squared, which is our c value, is negative 5 squared, which is going to be positive 25. Okay, so we'd like this 7 to actually be plus 25. And there's two ways to do this at this point. We could add the difference. So this is 7. We'd like this to be 25. We could add 18 to both sides of the equation. But instead, I'm going to show you another method. You don't even have to think about that. We're just going to move the 7 over and then add 25 to both sides. So we're going to have x squared minus 10x. We are going to subtract 7 from both sides. So we have that negative 7 on the other side. I'm leaving a little space here as a reminder that we're going to be wanting to add in our c value, which is 25. So we're going to add 25 to both sides of the equation here. So we're moving this value that was given to the other side, and then we're adding this b divided by 2 squared, in this case 25, to both sides. So kind of 2 steps in one here. So then this side of the equation, the right side, becomes 18. So there's that number, 18. This side of the equation, because this is a minus sign here, this just simplifies to x minus 5 squared this time. And if you're not sure about that, you can always factor it. We've got 25 here, negative 10 here, two numbers that multiply to positive 25 but add to negative 10 would be negative 5 and negative 5. So that's another clue for you. If you ever do the factoring for any of these, like here, you'll see that the number that you get here and here are the same. So here was 25 and positive 10. We should get 5 and 5. Okay, so there's a little, if you do need to factor, you can. But otherwise, whatever half of b is, that's what's going to go right here. Okay, so then we get this. We still need to actually solve. We haven't solved anything yet. So now we're going to actually use this method. We're going to take the square root of both sides. So we're going to get x minus 5 equals the square root of 18, plus or minus, right? And then we'll add 5 to both sides. And we'll get x equals 5 plus or minus the square root of 18. I think we can simplify the square root of 18, right? There's a 9 in there, so we can take the 9 out and we'll have 3 in front. So this is going to be 5 plus 3 times the square root of 2, and 5 minus 3 times the square root of 2. So that's what our x is going to actually equal. Okay, so that's a lot. But basically, you're completing the square, you're using these relationships, identifying b, take half that value, that's the number you're going to see inside your perfect square. You're going to square that number, add it to both sides of your equation. Once you isolate the x squared and bx term, so you're going to isolate ax squared and bx, you're going to isolate those. Okay, this is simple. Completing the square when a equals 1. It can be a little more complicated when a does not equal 1. So when a does not equal 1, then you need to divide the entire equation by a. Or factor the a out. Okay, and we'll do a separate video on that. Keep this one short. So this video is specifically for a equals 1. Okay, and then we'll do another short video when it does not equal 1.